we continue looking at the basics of electricity presented by Siemens Company. I have a link in the description of this video below where you can find this and other documents. Simple electric circuit. An electric circuit. A fundamental relationship exists between current, voltage, and resistance. A simple electric circuit consists of a voltage source, some type of load, and a conductor to allow electrons to flow between the voltage source and the load. In the following circuit, battery provides the voltage source. Electrical wire is used for the conductor, and a light bulb represents the resistance. The light bulb would also be the load. An additional component has been added to the circuit, a switch. There must be a complete path for the current to flow. If the switch is open, the path is incomplete and light will not illuminate. Closing the switch completes the path, allowing electrons to leave the negative terminal and flow through the light to the positive terminal. Let us have a look at it. We see here we have the battery, the bulb, the switch, and the wire. So you have four main parts of a circuit. You have the source, in this case the battery. You have the conductor, in this case the wire. You have the load, in this case the bulb. And you have the control, in this case the switch. The switch is open. No current can flow because you have a gap in the switch. When you close the switch, that means you switch the circuit on. Then electrons can flow through the wire, through the bulb, through the switch, round and round the circuit from the negative of the battery to the positive, and then the bulb will light. We look at the schematic diagram of an electrical circuit. The following schematic is a representation of an electrical circuit consisting of a battery, a resistor, a voltmeter, and an ammeter. Now, a schematic diagram uses symbols and various representations that really do not look like what they would. They don't look like the items that you would see in reality, but they are generally used, very simple and widely accepted. Up here, this is not a schematic diagram. This looks like a bulb. The person who draws this is trying to make it look like a real bulb, and for the battery to look like a real car battery. In this case, you use the symbol, the schematic symbol for the battery. This doesn't look like a car battery or any other battery. R, in this case, the resistance, and you can measure the voltage of the battery using this, which can be represented by a voltmeter. This can represent a voltmeter, and A, the amperes, This can represent an ammeter that you use to measure ampere. You can measure voltage and you can measure current in amperes. So this is the symbol or the schematic diagram for a circuit which uses symbols, and the current can flow around the circuit like this. So the following schematic is a representation of an electric circuit consisting of a battery, you see here, a resistor, which you see here, a voltmeter, which is here, and an ammeter, which is here. The ammeter connected in series with the circuit will show how much current flows in the circuit. The voltmeter connected across the voltage source, see that, connected across the voltage source, will show the value of voltage supplied from the battery. Before an analysis can be made of the circuit, we need to understand Ohm's law. Let's look at what that is saying. Ohm's law. George Simon Ohm and Ohm's law. The relationship between current, voltage, and resistance was studied by the 19th century German mathematician George Simon Ohm. Ohm formulated a law which states that the current varies directly with the voltage and inversely with the resistance. From this law, the following formula is derived: I equal E over R. Sometimes you might see I equal V over R. Remember that the voltage or the EMF can be represented by E or V. In other words, current is equal to voltage over resistance. Voltage divided by resistance. Now here, let's look back at this. The current varies directly with the voltage. When you have two quantities that vary directly, it means both of them increase together or decrease together. When one increases, the other one increases as well. When one decreases, the other one decreases. Which makes sense here, because if you put more pressure on the electrons to move, voltage, then more of them will move. That's current. You have an increased flow of electrons when you increase the pressure for them to move, to flow. And inversely with resistance, inversely, it means when one quantity increases, the other one decreases, and when one quantity decreases, the other one increases. So current and resistance, if you increase the resistance to a current flow, meaning that you try to hold them back even more than before, then the flow must decrease. So when you increase resistance, the current decreases. If you ease up, you remove the resistance, much of the resistance, and say, it's easier for you to pass. Come, we are not resisting you so much like before. Then you will have an increase in flow of electric current. So when you reduce the resistance, the current will increase. Ohm's law is the basic formula used for all electrical circuits. Electrical designers must decide how much voltage is needed for a given load, such as computers, clocks, lamps, and motors. Decisions must be made concerning the relationship of current, voltage, and resistance. All electrical design and analysis begins with Ohm's law. There are three mathematical ways to express Ohm's law. Which of the formulas is used depends on what facts are known before starting and what facts need to be known. Here you can just do a transposition, mathematical transposition, to get all three formulas. I equal E over R, or E equal IR, or R equal E over I. In other words, current is voltage over resistance. Voltage is current times resistance, or resistance is voltage over current. Ohm's law triangle. Some people call this the magic triangle. There is an easy way to remember which formula to use. By arranging the circuit, voltage and resistance in a triangle, one can quickly determine the correct formula. So if you want E and you cover up the E, you see IR. If you cover R, because you want R, resistance, voltage over current, you see E over I. If you cover up I, you will see E over R. I equals E over R. Current is volt over resistance. So this is the Ohm's law triangle. It is commonly called the magic triangle for some reason or another. Using the triangle. To use the triangle, cover the value you want to calculate. The remaining letters make up the formula. I is E over R, E is IR, R is E over I. So I is E divided by R, E is I multiplied by R is E divided by I. Ohm's law can only give the correct answer when the correct values are used. Remember the following three rules. Current is always expressed in amperes or amps. Voltage is expressed in volts, and resistance is always expressed in ohms. Examples of solving Ohm's law. Using the simple circuit below, assume that the voltage supplied by the battery is 10 volts and the resistance is 5 ohms. To find how much current is flowing through the circuit, cover I, because we want current, in the triangle and use the resulting equation. I is equal to E over R. 10 volts divided by 5 ohms is 2 amperes. So we have 2 amperes here, 2 amps. Now using the same circuit, assume that the ammeter reads 200 milliamp and the resistance is known to be 10 ohms. So you have the current and you have the resistance. To solve for the voltage, cover E in the triangle and use the resulting equation. E is IR. 200 milliamps is the same as 0.2 amps. 0.2 by 10 is 2 volts. Remember to use the correct decimal equivalent when dealing with the numbers that are preceded with milli, M, or micro, mu. Now they use the Greek letter mu. So this is the Greek letter mu. Or the kilo, K. Remember before they had mistakenly used M. So now they use mu. In this example, had 200 been used instead of converting the value of 0.2, the wrong answer of 2000 volts would have been calculated. So it's a matter of understanding the units and prefixes that you're using. The DC series circuit. We will look at the DC series circuit in the next video. So I will see you then.